Welcome all my dear student of FYBSc class. Today we are going to see the last point of this chapter, chapter 2, that is work and energy. And the title of this last point is gravitational potential energy. And after completion of this topic or this article, we are going to see some important problems related to work and energy. Now, first of all, we are going to see what is gravitational potential energy. To understand this concept, consider any material body and the earth. Any material body and the earth form a two-body system. A two-body system. What I say? Any material body and the earth form a two-body system. Though gravitational potential energy is shared property of the body and earth, the potential energy of the system is referred as potential energy of a body. What I say? Though the gravitational potential energy is shared property of body and earth, but the potential energy of the system referred as the potential energy of the body. Now, to calculate the gravitational potential energy of the body located at vertical height h above the surface of earth, for this purpose consider a body of mass m. Suppose that this is the body of mass m at point A on the surface of the earth. Now, the force acting on the body at point A is gravitational force, that is nothing but mg. Now, it acts downward. This gravitational force acts downward direction toward the center of the earth. Now, to move this body from point A to B with zero acceleration, a force equal to mg is required, or the force equal to mg must be applied on the body in upward direction, and so that the body comes from point A to point B. Now, when this happens, at that time work done by the applied force on the body, is nothing but work done is equal to work done by the applied force. Applied force on the body is equal to what? Force into displacement. What is force? Force is gravitational force F into displacement h. That means body moves from point A to point B, and F is nothing but mgh. Therefore, this is the potential energy. Work done. This is the work done by applied force on the body to move from position A to B. But this work done is stored in the body as a gravitational potential energy at point B. Therefore, potential energy at point B is equal to mgh. Capital M, mgh, where m is the mass of the body, g is acceleration due to gravity, and h is the displacement or height or altitude. In fact, this is the change in potential energy. Here the potential energy is 0, and this is here at the point here the potential energy is mgh. So, change in potential energy is nothing but b minus a, mgh minus 0, and you will get mgh. So, in fact, this is the change in potential energy of the body in moving from position A to position B. But as we are taking the potential energy at point A is 0, So the potential energy of the body at point B is equal to mgh. Okay, I think this is sufficient for gravitational potential energy. Now we are going to see some important problems. Related to work and energy. Consider the first problem. In this problem, we have to find out the work done in moving a particle along a vector r is equal to suppose 3I minus j plus 4k. This is the direction, or we can say that the particle is moving along this vector r in meter. In order to move this particle along this vector, the applied force F is equal to I vector I plus j plus 5k, or we can say that 3j. Okay, and this is in Newton. See here, suppose this is a particle, this particle is moving along this vector, and this is nothing but 3I minus j plus 4k, and the force acting on this particle to move along this vector is nothing but this F is equal to I plus 3j plus 5k in Newton. These are the given quantities. So, solution given, there are two quantities R and F. Now, in order to find the work done on the particle by the force F, we have to use the formula work done is equal to force into displacement. Okay. That is nothing but simply F dot R. So, what is the value of F? I plus 3j plus 5k dot 3I minus j plus 4k. When we solve this term, remember that we are going to use the vector quantity, vector product I dot I, vector I dot I is equal to vector j dot j is equal to vector k dot k is equal to 1, and vector I dot j is equal to vector j dot k is equal to vector k dot I is equal to 0. By using this property in this equation, here I into 3I 3 plus 3I into j, or we can say that vector I dot vector 3I is equal to 3 because I dot I is equal to 1. Then 3j dot j minus 3 j dot j is equal to 1. Then plus 5k dot 4k is equal to 20. Therefore, 3 is getting cancelled with minus 3, and we have 2 0, that is 20 joule. This is the work done by the force F on the particle. Okay. Now I am giving you the same problem for homework, only there is a small change in the values. By using the same method, you can solve this problem. The change is 3I minus j plus 6k, and again I plus 3j plus 2k. I make only two small changes in vector and force. when you are going to solve this problem, you have to use the same method as I use here. And when you use this, when you solve the same problem by same method, this problem by same method, then answer will be minus 12J. Okay. This problem is frequently asked in question paper at various times. Now we are going to see the next problem. In next problem again, I am going to tell you that problem. A body of mass 100 gram is thrown vertically with speed 10 millimeter per second. Sorry, 10 meter per second. And we have to find out the work done by the force of gravity during the time the body goes vertically up. Suppose this is a body. We throw this and the mass of this body is 100 gram. Okay. And we throw this body in upward direction with speed 10 meter per second. When we throw this body whose mass is 100 gram with the speed 10 meter per second, now we have to find out the work done, W, done by the force of gravity during the time the body goes vertically up. सिंपल प्रॉब्लेम आहे. एक बॉडी आहे, तिचा मास 100 ग्रॅम आहे आणि तिला आपण 10 मीटर पर सेकंदने वरच्या बाजूला फेकतो, वरच्या दिशेने फेकतो. त्यावेळेस आपल्याला वर्क डन करायचं, काढायचं. पण वर्क डन कसं असणार आहे? वर्क डन बाय द फोर्स ऑफ ग्रॅव्हिटी or gravitational force during the time to obtain or the body goes vertically up. So solution given here, m is equal to 100 gram and v is equal to u, initial velocity, u is equal to 10 meter per second. So here one quantity is given in CGS and one quantity is given in SI. So convert this quantity in SI, 0.1 kg. We convert mass into kg. Okay. Now since so, see here, when the body reaches to maximum speed at height h, suppose this is the height, this is the ground surface, this is the height. When the body reaches to some maximum height h, at this point the velocity is 0. Final velocity is equal to 0. And what is the initial velocity? 10. Okay. Now since the body is going up and gravitational force is vertically upward, work done by the gravity is negative. Work done by the gravity is negative, that is minus mg h. Why this is negative? Because work is done against the gravity, because body is moving vertically up. So the work done is negative. Now the maximum vertical height may be calculated. What I say, the maximum vertical height h may be calculated by using the formula v square is equal to u square minus minus 2gh. This is very popular formula. You studied this formula in 12th science. Here, when the particle obtained the maximum height, the velocity, final velocity is equal to 0. So 0. Square of 0 is 0. And what is the initial velocity? U, 10. So 10 square of 10 minus 2 into 9.8 into h. So solve this, we get 100 minus 19.6 into h, or 100 is equal to 19.6 h, or h is equal to 100 by 19.6, and this will be 5.1020 meter. This is the height. Okay. You obtained height. Now this is the height. You are having the mass and you are having the value constant g. Therefore, by putting all these value in this formula, we get the work done, and that work done is nothing but W is equal to minus y minus against the gravity. So what is the value of m? 0.1 into g 9.8 into h 5.1020, and when you solve this we will get 4.998 joule. This is the final answer of this problem. Okay. Now same problem can be solved by another method. Same problem can be solved by another method. See here. See here. What I say? Same problem we can solve the same problem by another method. That means what? By using work energy theorem. What is work energy theorem? W is equal to change in kinetic energy, that is final kinetic energy minus initial kinetic energy. Now here we can write 1/2 mv square minus 1/2 mu square, where v is the final velocity. When the body obtained maximum height, at that time velocity is equal to 0. Therefore, when you substitute the value of final velocity to 0 is equal to 0, then you will get 0. And 1/2 mass is nothing but 0.1, and initial velocity is equal to 10 square. And when you solve this, you will get same answer, that is 5.00, which is very close to this. 4.998 is nothing but minus 5 joule. This is the work done by the gravitational force acting on the body. This is the another method, very simple method. Now I am giving you a same problem, a problem for homework, and you have to solve the problem by using same method. Only I am going to change, instead of this mass 30 gram. That means when you are going to convert it, its value will be 0.3 kg, and initial velocity u is equal to 15 meter per second. So solve this problem by the same method as we use here, and when you solve the problem, it will find out answer will be, work done will be W is equal to 3.37 joule. Solve this problem by both the method. Okay. Now the third problem. Now again in third problem we are having a body of mass body of mass 4 kg. Again there is a body and having mass, and this body is at rest, initially at rest, and subjected by the force 16 Newton. 16 Newton. What is the kinetic energy acquired by the body at the end of 5 seconds? 5 seconds. See here, understand the problem. There is a body whose mass is 4 kg. Suppose this is a body whose mass is 4 kg. Now, when we apply the force of 16 Newton, what is the kinetic energy? When we apply the force 16 Newton, what will be the kinetic energy of this body at the end of 5 seconds? Okay. So, see here, when the body initially at rest condition, that is initial value u is equal to 0. Okay. Now, in order to solve this problem, what is the final answer? We have to find out the work done by the force F, and work done by the force is nothing but W is equal to Fs, where S is the distance covered by the body in the direction of force, and second thing, finally we want to calculate the kinetic energy, and that is nothing but 1/2 mv square. So by using both this formula, we will solve the problem. So, see here, according to Newton's second law, what is Newton's second law? Force is equal to mass into acceleration. Now, we are having the mass of the body and we are having the force of the body. So, we can calculate acceleration of the body, F upon m, and this is nothing but force is 16 Newton and mass is 4 kg. So, acceleration is equal to 4 meter per second square. This is the acceleration. Okay. Now, distance covered by the body at the end of 5 seconds. Distance covered by the body, that means we have to find out S after 5 seconds. So, again there is a formula, S is equal to ut plus 1/2 at square. This formula is also studied by you in 12th science. In this formula, here u is initial velocity and value of initial velocity is 0 because initially the body is at rest. So, when you solve this by using the value of u is equal to 0, you will get u is equal to this is 0 and finally 1/2 at square. But we calculate here at, what is S? S is equal to 1/2, acceleration is 4 and t is equal to 5 square. So, 1/2 into 4, that is nothing but 2 into 25 and this is nothing but 50 meter. This is the S. Okay. Now, by using this formula, lastly we can calculate work done. So, work done, W is equal to Fs. What is force? 16 Newton. And what is distance? 50 meter. So, work done is equal to, when we take the product of 16 into 50, we will get 80 joule. And this is the work done. Okay. Now, by same method, you can solve the problem by another problem. Okay. Now, here we are going to calculate the kinetic energy. Okay. The kinetic energy. What is kinetic energy? Because when the body moves from one place to another place, obviously, according to work energy theorem, we know that what is the work energy theorem? W is equal to Kf minus Ki. If change in kinetic is nothing but, this is the change in kinetic energy and work done is equal to kinetic energy. Hence, kinetic energy of the body will also equal to 800 joule. Okay, remaining problem will be solved in next lecture. Till then, we shall stop here. Have a good day.